Moving on to number 6, we can see that we have a 30-degree angle and a 90-degree angle, so we can automatically assume that this would be a 60-degree angle here. We want to use what we know about special right triangles, specifically 30, 60, 90. Across from our 30-degree angle, we know that this is S. Across from our 60-degree angle, we can also label this S root 3. And across from our 90-degree angle, we can call this 2S. So right here, when in your closing statements that you have to check off, set up an equation for special right triangles and solve. This is exactly what I'm talking about. In this equation over here to the right, 2 root 2 equals S root 3, we can go ahead and solve this by getting S alone. In order to get S alone, we want to divide by the square root of 3. Over here they cancel, and I'm left with S. Over here on the left side of the equation, we have a radical in the denominator, and we know that that's against our rules. So we want to go ahead and get that radical out of the denominator. The way we get that out of the denominator is by multiplying by the square root of 3 to the top and the bottom. So take the square root of 3 times itself. We would have plain old 3 in the bottom. Again, we want to do that to the top as well. So the square root of 3 times the square root of 2 is the square root of 6, but we still have this 2 right here. So 2 root 6 over 3 is our S value, which again is this side over here. So we have 2 root 6 over 3 for this measure. And then when we substitute S in over here, our 2 root 6 over 3, we also want to bring this 2 back down. So really we have 2 times 2, which is 4. 4 root 6 over 3. If I could simplify, I would, but in this case, this is the simplest radical form. So in our closing statements, never leave any perfect square factors under the radical. 6 can only break down into 3 and 2, so it is completely simplified. Set up an equation and solve. We did that over here. And this one right here applies to number 4. Put the hypotenuse alone using a squared plus b squared equals c squared.